right. So hi, everyone. Really thank you for coming. It's so cool that you are doing this also voluntarily in your free time, like listening to some additional stuff to your studies and whatsoever. Oh my God, there is some weird, right? Well, I hope not to. We'll manage it. And I really also thank BLISS for inviting me. It's quite exciting. I hope the talk will be interesting for you. It's also fairly technical, but not too technical. So we'll see. If you have additional questions, you're welcome to ask them, especially after the talk. So basically, the idea about this talk, the role of AI in disinformation resilience, it's obviously not only about the role, but about also the applications. Basically, I wanted to start like a bit from the idea of where or who is interested in such applications, really like what are the stakeholders. And one of the main ones with whom we usually work are actually journalists and fact checkers, right? Because it's kind of difficult fight against disinformation. We are always losing because it's much easier to make a lie than to fact check it, and it needs much more resources. So automatization is like the obvious way where we want to go. But then obviously there are some problems with it because especially in Germany, for example, fact checkers are bound by a lot of laws on media regulation, and obviously like reputation is above all for fact checkers. Then business is interested in, so like even weird animation. Even if we think like of the big thing, but to be honest, not only, because a lot of companies nowadays would monitor their assets. And for them, it will be really important to kind of, and this monitoring actually is going through social media, and it will be interesting and important to basically filter out things which are like truthful posts from not truthful posts about, I don't know, like disaster or fire or protest near their assets. And then government is also obviously interested, right? And even in Germany, there are like at least 4 different ministries which are funding all of this research and like work on media monitoring and disinformation resilience and whatsoever. Well, my work is usually funded by BMBF, so the Forschung, research and education one, but that's not the only one interested, let's say. All right, so let's start a bit from social media moderation, kind of a topic where we use this in information disinformation resilience, larger field. And here I worked especially in my PhD time with my co-authors I already want to put here. So it's obviously always collaborative work, right? And basically why we want to do it, why we want to, right? Because obviously freedom of speech is great. And on social media, this is something what we want. But then we also know all of these crazy statistics, for example, about teenagers and teenager suicide being often caused by harassment on the media. Actually, it's not only like teenagers, it's most of the groups we want to protect, which get especially attacked in this anonymous kind of environment of the internet. Right? Oh, no, I think that's a bit too quick. And then why we want to automate it. So on the one hand, I already told you that this is a kind of a fight which is difficult to lead because of the speed of fake news creation. But then also human moderators actually usually have to go through immense trauma on looking at these messages. They are usually hugely underpaid. They're usually also outsourced, like in developing countries, and paid like 2-5 euros per hour, which is why we want to at least help them with some automation tools to maybe a bit filter out the vast amount of information. And also there is a lot of lack of transparency and adaptability in this field, in a sense. I mean, lack of transparency also without AI. We don't know why we are flagged, why we are banned and whatsoever. With AI, that can be obviously only increased, but well, obviously explain about AI here also gives us a lot of opportunity. And then in this sense, it's very important also to remember that now in EU, there is this AI Act, which according to which also social media moderation with AI would be binded to. It's a bit wishy-washy, if you ever wondered. But in a sense, it really is important, not the part that AI is used. Countermeasures are then applied after this AI decision, and then basically this consequences of mismoderation are obviously a big problem, because on the one hand, if we banned, for example, a person based on AI decision for just some normal discussion, like neutral discussion, just because there was some word which like kind of triggered our system, this is a problem. But also if we don't, for example, in Germany, it's one of the stricter rules, basically. So if, according to which the platform has to delete obvious hate speech, for example, in 1 week, and in 2 if it's implicit one, right? So this is kind of complicated for the platforms to do. So we basically want social media moderation to be accurate, adaptable, and transparent. And so it's difficult because there are so many phenomena we want to catch. I personally worked on propaganda detection and focused on it. And this was basically one of my side tracks, my pet project of my PhD, which then eventually actually helped me to do it quicker than I would expect only from the project which was funding me. So basically there are a couple of papers I'll show you here from that research. And this first one, we were looking into how to make it accurate and transparent, how to make propaganda detection resilient to time, because obviously it was shown that big events are changing the data so much, and language data so much, that the models really can't catch up, and we wanted to a bit like evaluate it, and also how to empower the lay user. Actually, that's 3 papers. That's not one paper. And the first one is about this accuracy and transparency. So I focused also a lot on pro-Kremlin propaganda in my work, but to be honest, it's not only me because I'm Ukrainian. To be honest, like absolutely every lab in Germany now focuses on this particular data because there is just a lot of it. The idea for it was born on 21st of February, after just watching the first speech from Vladimir Putin. Then I realized that something is coming. I just started scraping data, and I was scraping it at the beginning of the basically till 4th of April. And me and my co-authors also were doing it for multiple languages, like Ukrainian, Russian, English, Romanian, and French. For that, we were using web news articles, which are easy to scrape and a bit basically available. And then we also scraped Telegram news, which is now a holy grail of data science in a way, because it's almost the only social media which still allows you to scrape data and like easily, which might sound nice from data privacy perspective, but then for academics who want to like genuinely analyze the social processes, it's very annoying. And basically what we did, we annotated our data based on weak labels. This means that we took journalistic investigations, different proxy service, which basically analyzed the bias of different media. And based on that, we attributed the labels on like it's also a bit difficult, obviously, in the case of propaganda detection. I usually say that it's quite coinciding with stance detection, and we would say like pro-Western or neutral, and then Kremlin sponsored. So the idea is to just dissipate pro-Kremlin from all of the rest, I would say. And then basically what we did is we started with just very basic things. So you might think, okay, BERT is like so out of date, but I would assure you that also working in the startups and like a little in the industry, it's actually so much like so used because LLM is so expensive. If you just use GPT, which looks cheap, you are just third party dependent. So to be honest, it is a bit out of date, this research, but it's also still quite used. Even more out of date, we actually compared BERT model to statistical model with linguistical features, and to be exact, the SVM. Surprisingly, it will actually be not bad. So with these linguistic features to be used, keywords and features of like linguistic features of the language, basically. I'll not go in all of them. You can read them in the paper afterwards if you want. But the idea is that, so I handcrafted them all, like in all times, morphological, syntactical, and semantic. And the idea of them is to catch this kind of a style of propaganda, which in a way based on our hypothesis, is a bit more withstanding to time, which actually also was true because, right, topics change, especially in war, quite quickly, but then the style kind of stays there because it's done according to some playbook, let's say. So you can see here some things which just show emotional part, or like negations, for example, weirdly enough, were shown to co-occur, like correlate a lot with non-neutral news and with fake news and stuff. And then personal pronouns like are showing a bit more opinionated news than in syntactical structure. For example, clause of reason is used for justifications, right? And in semantics, all of these things are also a bit shown in the literature to be quite frequent in fake news or propaganda. So such as abstract nouns like liberty and freedom. So, a bit of this slogan stuff. And also high modality words. So something like definitely, surely, allegedly, that's my favorite. And also all of this like emotional lexicon. Anyways, yeah, so I kind of already explained that just now. And we basically can see that BERT performed quite much better, 92% F measure, right? So this is a harmonic average between precision and recall, just in case. And SVM with all of its linguistic features perform at 88%. But the cool thing about SVM is that it's not a black box, and we were a bit able to also draw some results and understand what was special about this particular data, while BERT was a little bit more black box, although we'll come back to this. Yeah, so we also did actually reverse ablation study. I call it recently like that because I realized I created a bit of a particular method for explainability, which I think I still have to publish somehow at some point, pointing out that it's really new. And then in the SVM, we did just a very simple coefficient analysis. So what's the idea of this reverse ablation study? We just basically chunk the tokens of the sentences into tokens, very typical thing we do in NLP, right? And every time we basically we start from first token, and then every time we add the next one to rebuild the whole sentence. And by this, we basically are able to see how prediction changes. So what's the change in the probability of the class with the addition of each new token? So this sounds simplistic now, not much different for now from the things others do. But basically, the idea is that we then gathered this kind of results into three groups. Tokens changed the whole prediction. Token changed prediction by more than 30%, and no major impact. And then we also took this token and categorized them linguistically into basically different linguistic categories. And basically, in general, we're trying to use the same pipeline and just annotated these tokens with our linguistic categories. And we were able this way to basically not only say what word was important, but also like what category was important statistically. So interesting results were that, well, adjectives are important. I mean, it's kind of obvious because neutral news would usually not have too many adjectives, right? High modality words, as I said, like all of it, certainly, never, a must, right? So modal verbs, whatever. Abstract nouns, I already said. Reporting words, so that's like we surveyed, we asked, we presented, whatever. And then also terms with negative, strong connotation. So, and also strong positive connotation, which is kind of obvious, but also nice to see it in data. So how resilient such detectors are to time? This is the second paper where we looked at the evolution our model after 1 year into the big war in Ukraine. And we basically collected more data in January 2023. So we just took the same model and checked it on the new data. And we saw that actually it worked better than initially. We were like, oh, wow, okay, not bad. So it is with BERT. With SVM, it was a little bit worse, not much worse. So we actually felt like we're cool, or maybe data doesn't change that much as people usually say. So what we also did is we looked a bit into error analysis. we looked on, again, this linguistic, I do a lot of linguistic analysis because I think that's my kind of a strong point in AI, where I'm not coming from super mathematical background. So we again looked at averages of different linguistic features in all of these error categories. So like true positives, true negatives, false positives, false negatives. And we were able to see that many averages, at least, were actually becoming quite similar between true positives and false positives, which actually was creating a lot of these false positives in the end. We also printed basically, basically looked at the difference in distribution between also different subsets in first year and the other. So we used the same sources so that we are a bit more coherent. And we saw that, for example, in the Romanian data, there is like much less emotions actually. And in actually most of the others didn't change that much, but like Ukrainian Telegram also changed a lot, and like Ukrainian news in general changed a lot, became actually much less emotional as well. And then finally, how do we empower lay user with such models? Do they even care? So this is third paper, check news in one click. Very, very stupid name, to be honest. I even have a domain like that, and it really looks like spam. Like, so people are afraid to click on it. But well, yeah. So the idea here is that before we were taking a multimodal approach, multilingual approach. So we just took one multimodal BERT, fine-tuned it on all of his data together, and then looked what happened. Worked all right. But with German and Italian, we also use with weak labels, which is a bit bad because we might have still got some neutral news, even though we were doing some filtering. So I don't know, news about zoo in Moscow, which was actually neutral. So in German and Italian, we were lucky to actually find annotated data. It was done by VoxCheck. They have this propaganda diary. And the idea is that they have annotated huge amount of German articles and also Italian articles in containing propaganda and like exact narratives, basically. So that was nice. We could actually train a strong label model. And we first still were like, okay, let's do a multimodal approach again with German and Italian together. And it was actually working pretty bad. So especially with Italian for some reason. So we decided to do language-specific model this time. And we saw that it actually worked much better in a sense. So maybe at some point it's a good idea to revisit basically the previous models. And what we also did, because this was not so much data, it was like around 2,000 per, or like a bit less, like 1,500 per language here. We also decided to augment it with translated into these languages, Russian and English data, which we were kind of sure that they are like propaganda or not. And basically, we saw that actually augmentation can work kind of language specifically. So for German, we can see that it actually helped a bit, and for Italian, it didn't. So the quality dropped. So in a sense, it can also obviously be due to the translator quality. So maybe translator works just better for German language than Italian. Wow, no surprise, to be honest. That's unfortunately how it is. Like I think in Europe, generally the French and German, except for English, would work the best, like in NLP tools which are available. And then all the rest is like going worse and worse. But yeah, and then we made this very spam clicky whatever website to be able to interact with some users. And another thing we did, and it was also the idea of my thesis, a little bit like the umbrella term, with which I was able to put huge amount of absolutely non-related stuff into it, is the hybrid AI system. So the idea is to take different elements of AI of different nature. Usually when people talk about hybrid AI in this sense, they would also think to add a reasoner, like semantic parser whatsoever, in addition to a neural network. But to be honest, it can be anything. And in my case, it was together BERT and SVM and some additional heuristics. So the idea is that BERT, because we know that it's just better at just predicting purely, was used as a predictor. So we took the prediction and took its probability of the class. And then on the other side, we took an SVM. We also extracted the features. If SVM was super disagreeing with the BERT, we would basically change the probability attributed by BERT by around 30%, depending on the case. And we would also show to our users the indicators we found. So the keywords and the explanations to these keywords and the explanations to the linguistic indicators which we found. User study was a bit like that. So I'm not a user study expert, but like somehow when you work in academia in AI, you should become it, because that's a bit of a way to publish a bit easier, I would say, or like give a bit more credibility to your results. So one thing we did is we took user inputs of news, and we also asked them if they thought that what they proposed to us, what they checked with our tool, is propaganda or not. Basically, in this sense, we received this kind of user labels. And then we also had a post questionnaire, so the users could play with our tool and then answer some questions. We recruited them, by the way, by different social media. On Reddit, people are quite willing to answer you. So yeah, that's also, it's a bit of a demographic bias, but still. And then, yeah, so basically that was how it looked like, right? So do you think it's propaganda? And then the questionnaire. All right, so in the end, the 2000, well, that would be nice, but 200 users, we got quite positive feedback. 79% said that they learned something new. We also asked if they would recommend it to friends, to older relatives, or to teens, and actually most said to friends. And then we also said, because we always were feeling like website is actually not the best way to use it. And we proposed some options, and most say that they would like to have it as a browser plugin. So that basically while you read some news on the internet, or even like you're on social media, there can be like an additional disclaimer out of nowhere, like flagging that, oh, that can be potential propaganda on what you look like. I'm not sure that would work very nicely, especially if you like accidentally get lost on Twitter in some weird thread, but well. And then model output correspondence with user labels was kind of interesting because it was very bad. And it's not only because our models are bad, mind you. You can see also the German model, which was actually the newest, the kind of the best data trained, actually had the worst results. But I mean, it also had a bit less respondents, but still. And then the best one was actually Ukrainian. So we were like, okay, why? And we have a couple of ideas why. So on the one hand, that's also the problem of giving things you created to actual people. They go wild. They like you tell them that you used like, okay, we trained it with news, please check some news, but they give you comments from Reddit. They just create some weird sentences themselves, and they expect the model to like just work out of the box. I mean, especially because not our users usually are not technical, like AI, I don't know, educated or something. And so basically, the entries we got were quite, so you can see blue, it's user entries, length of the text. And then our trained news, conventional news was like quite large. So each input was quite big. And then Telegram news would be like quite small, and user entries were right in the middle of it. And I'm pretty sure that actually, so basically with shorter entries, it actually worked better. And then, yeah, so for example, we got something like that, which is like a recipe for gherkins, pickles, right? And it was like, our model was like, yeah, propaganda. So that was a bit embarrassing. But overall, linguistic features, the users, so basically we still checked ourselves if basically the, what was the correspondence of really neutral news and non-neutral news. So basically, let's say a lot of things that our users annotated as non-neutral or as neutral, it's like, it's okay, it's good news, was actually often not. So basically the users are often overconfident about what they give us. And that also kind of showed us a lot that, people are usually already, they usually already know if they believe this source or not. And this is a bit of the problem. So now I move a little bit into what I was doing last year, and that's tools for fact checkers. I'm working in BMBF funded project No Fake here in TU. Also, we have a large, cool team partners in Ruhr University Bochum and TU Dortmund and Correctiv, which is one of the biggest fact checkers in Germany. And you might have seen them a lot on the media. They had a lot of trouble with, politically, let's say. And the idea is that, we all have something to do here. My group mostly focuses on multimodality. We also create learning videos to explain our tools to journalists, because we realize that if we don't explain actually what our models do and how they work, they actually have much more skepticism, and they are even afraid to touch them. They would just do the usual stuff. So that's why we do it. And I also do a checkbot. Amazing name, I think. It's basically a RAG system, as you'll see. But then basically we also create a Fakten forum. It's a community of crowdsourced journalists, but actually that's a bad term. We say citizen journalists who just engage into this fact checking and are willing to learn to fact check. So if you have time and interested, you are welcome to join. And that's also funny, because the demographics we usually get is actually very old people or students. No one else cares about democracy and disinformation, or have time for it, I guess. And then in Bochum, they work a lot with knowledge graphs, and into they're actually our legal team. When we don't know what to do with AI law, we go to them and we cry, and they explain us a bit you'll not go to jail for this and stuff. So we focus a lot on generated content nowadays, because it's one of the things that fact checkers actually accept as a tool. So let's say, because if you ever come to fact checker and propose your model, which says this thing is fake, or no, it's not, they would just not do that for sure. But what they accept is basically trying to check if there are some artifacts and whatsoever, which they can quickly see, and then okay, this is at least generated. Now we can also confirm if it's fake or not. And this is a recent paper, and the idea is that now we expect AI, text generated by AI, to account for at least 10% of all data produced by 2025. For now, feels like not the death of internet, but actually going in that direction, right? And on the other hand, most of the tools, which you maybe already even tried, for detecting all of this, ChatGPT and stuff, is usually working well for English or created for English text, but not for other languages. So we decided to, and we were, to be honest, funded to do it for German. And Correctiv also works, especially with German media, so that's why they're interested in it. And we also tested with Zero GPT, which is the biggest kind of competitor. It's not too good. I also was in iClear conference this year, where we were just two stands, basically one behind the other, or in front of the other, basically one paper criticizing the previous version of Zero GPT, and then the next one is their new version. That was a lot of fight potential. And the idea is that we also wanted to create a tool which would look at different models. This is, again, kind of a fight you can't win, because even though there is a talk about watermarking of the text, and the big players like OpenAI is actually interested, because at some point there is so much generated text, they will just learn from generated text they generated themselves, and this is ridiculous, and basically the performance will stop, performance rates will stop. But we have huge amount of open source solutions, which is amazing, and we want them, but they sometimes are not interested in that, or don't have resources also to go into that direction. So we took a couple of models which are working well, producing German texts, Llama 2, GPT 3.5, and Mistral, and especially their fine-tuned versions. So, for example, for Llama 2, it's Snoozy Wizard. You can check them out in GPT for All library, very nicely packaged and easy to deploy, let's say. And we scraped a lot of data, which would be in the like kind of the genres where we expect the fake news to kind of appear. So, for example, some papers, news, social media, creative content. I don't like it too much, but it was, oh, sorry. Yeah. If someone knows how to make it stop, I would be open to it because it's very annoying. Yeah, so that's basically the setting. And then we took first 2 sentences of the human texts we collected and prompted our LLMs with that. And basically giving it some token limitation because otherwise it can go for days. And then AI-generated texts we got were on the same topic as human text and in the same kind of length, but different, right? And we actually took Distilbert, even smaller, right? But we tested like XML Roberta, Electra, BERT, and actually Distilbert worked the best somehow, also being like the quickest to fine-tune. And what we did is we also tested a couple of hypotheses with this like generalizability of such models. So, for example, we had a setting with only 1 generator data, so only a lot of Llama 2 data and human data. Then we had a setting many generators, but less data. And then we had more like all of the generators we could find basically, and more data, but like still like not huge amount, let's say. We call that Llama data model, mixed data model, and complete data model. And yeah, there were a lot of test sets. Let's maybe not look too much into that, but the idea is that, especially option 1, is that we had one test set where it was seen model, an unseen genre, an unseen model, but seen genre. Try to let it sink. It's a bit probably complicated, but the idea is that we want to see if the model can find similar. So basically, the new data points which are from a new generator. So is it just like really sticking to the artifacts or like kind of the style of generators? And if it's also really, so if we didn't show it like some new genre, like for example, Reddit comments again, would it like really mind? All right, so Llama model looked amazing by itself. So you see, we have a huge amount of all of this metrics, really usually recommended to my students, like do all of the metrics around because at least that will not be a question on your defense. And then, but then we also tested it on all of these test sets and on mixed test set where there were some generators it didn't see, it already dropped considerably. And also on this GPT test set, it was quite bad, especially in recall. So it means that it was sending like everything it didn't know to human texts. So basically, which is really what we don't want to, right? And on Mistral, which is like absolutely also non-related, unseen model, it also was even worse, right? So the mixed model, where it already was a bit of not much data, but a lot of different generators, performance dropped a little bit, like on itself. It also dropped on Llama in comparison to a model which was only trained on Llama. But it was already much better on unseen genre and unseen generators, to be honest. And then the complete model, where we were like everything, we just like, we throw everything here. We see actually, again, worse performance on itself, like on the same data from the same distribution, but a much better unseen tests and unseen, basically, genre. Also, a very important thing when you work with like such models is to check the calibration, especially when we have so many different subsets, right? So basically, it's estimated calibration something. ECE score. And we saw that, so basically, it's good when you have like almost very, very, very small, basically almost like 0.1, 0.01, whatever calibration, that's like amazing, never happens. But like below 20, it's okayish. 11, very good. So basically our best model is also the best calibrated one, which is not such a big surprise. And what we also wanted to do is basically to check, to compare what humans see in generated text, which is a bit complicated, right? So we not always can find it, although sometimes it's pretty obvious when it's like, sorry for the confusion. I meant BLISS or something. But basically also what the model itself sees with like using explainability methods. Okay, my linguistic features are back, more of them, they're different, but the idea is that here I added some stuff to catch the generation artifacts. So we saw that still, especially Llama was creating a lot of stuff like just repeating some sentence. It generated like multiple times until it reached the token limit we set. It could also be that it was like using zero co-reference, let's say. You see, like we went to the lunch was great. So kind of not many words, very, very limited vocabulary. And also it was not very informative. So this is something we wanted to catch. We calculated basically the mean, medium, and maximum sentence similarity. So we took every sentence in the text and we compared its similarity and took average, mean, or maximum of it. We also looked at repetitive lemmas. So lemmas are your basic form of a token. So for example, it's a bit linguistic machism, as we say, but if you, especially in German, that would be very obvious. So if you have a female plural, it would become like female singular, let's say, and that's lemma for you. It just helps you to do statistics a bit easier, because then the words like lererinen and lera would be like, you still will count it once, like as one thing, which can be useful. Then also sentence length variation and functional to lexical word ratio. Like functional are like articles, adverbs, or not adverbs are good, prepositions, and then lexical are nouns, adjectives, adverbs, and verbs. So basically to a bit catch the information to, I don't know, nothing. It's very kind of simplistic, but still actually worked. So first we looked at the average analysis. You can see that all of this in the end, so out of all that I showed you, actually this generation error features were the most important in the end. So we can see most of them here. Out of the interesting ones was adverb to verb ratio. So basically we can see that that's delta between averages of human and generated texts altogether. And they were normalized and whatsoever. But the idea is that adverb to verb ratio is bigger in in human texts. Okay, I don't know how to read it in generated text, I think. Yes, and then in generated text. And then maximum sentence similarity would also be bigger in generated text, but on the average human text would actually be more similar between sentences. So that's a bit showing a bit more coherence and cohesion in the human texts. Also interestingly, neural sentiment probability, right? So a bit bigger in human text and stuff. What else we did? It's a PCA test, right? So we looked at volatility of our features. What is a lot of, again, generation error stuff is here. You see repeating lemmas, description, adverbs, neutral sentiment. But we also found a lot of other categories. Like, for example, sentiment was generally important, right? So negative sentiment and positive sentiment would actually be more present in like llama texts than anything else. And then post text, so this part of speech text, like nouns and verbs and adverbs would also be quite differentiatable. Pronouns, very differentiatable into human texts, interestingly. And then also syntactical features like amount of simple sentences, subordinating conjunctions, and complex sentences was also, you see, like a lot of stuff is basically going in the direction of human. Also interesting thing is that Wizard, so Llama 2 fine-tuned version, was the closest like in style to human texts. That was interesting. Especially because GPT 3.5 already would like look a bit better in a sense. So again, basically the most important features with like statistical testing and stuff were foreign words, interestingly. So that's already going into direction that I tell you that our models learned racism. So you'll see. And then maximum sentence similarity, discourse markers are like firstly, secondly, so you know that GPT, for example, used it much more than humans, so that's a bit clear. Positive sentiment similarity, humans would write less neutrally, right, than GPT actually, or like generation. Amount of analysis is also like the biggest in human texts, and repeating lemmas is like more typical of llama and actually human text as well. So I'll not go too much into this actually. All right, so if we compare basically what we found with LIME, so it's a model agnostic explainability method, we can see that it basically just found foreign words were important. So we had like explore, bibliografia, or bibliographia, I don't know. And then with human kind of analysis, we saw a huge amount of stuff. So interjections, politically loaded terms, and am I saying it right? Yeah, I think. There was also so basically politically loaded terms were, I'm sorry, I reading it absolutely incorrectly. So with LIME, we saw that in human texts, there were interjections, there was a lot of politically loaded terms, which would otherwise apparently a bit difficult to generate or like unexpected to be generated, like, this Kinderarmut, dictator, so Berufsdemonstranten is like workers' protests and stuff. Then creative usage of German language, like not geil, Idealfall, whatever, weird. And then words describing human subjective experiences. That was also interesting and maybe worth looking into more. But basically in human tests, there would be more stuff like trauma, physical, or getting on weight and stuff. Geflug, I actually don't remember what it means, but like we also put it into this category. And basically in AI, we only could found that there are more foreign words. And then with gradient analysis, which is another method, which is a bit deeper, I would say. So it looks a bit, it uses the backpropagation and like kind of maps from input to output a bit more like the importance of words using gradient analysis. And then with human text, we could attribute German like classical names, like especially male ones, like Klaus, Richter, Dietrich, Johannes, Philip. Well, Philip is nothing bad about Philip if there is a Philip here. So the idea is that if the text contained this all German names, it would think that it's human. And if the text contained like more foreign names like Marlene, Scott, Nicole, Castro, whatever, it would think that it's generated. So that's what I meant. And then some other stuff was like cities would also be a bit more biased to for AI decision. So AI generated texts, abstract foreign nouns like terrorism, irrational, proportional, some organizations as well. So basically, what is also important to disclaim is that we found no correlation between the bias of the term and how frequent it was in our training data set. So it was not basically attributed to, okay, the model just saw that a lot or not. So to conclude rather here is that human analysis found much more stuff in the end than explainability analysis. So it means that our model, well, in a sense, it's still, there's many things to learn, or like to be able to also differentiate these things, which it's not learning probably. So yeah, there is basically a lot to do in a sense. And yeah, that's a bit of the thing which was post this research. We submitted this paper and Llama 3 came out and GPT-4o came out. So we obviously were like, interesting, does it work? Well, so interestingly, our complete model, the best model, let's look only on this one, don't look on Mix and Llama, they're awful. It actually works quite well with Llama 3, which it never seen, because it saw a lot of Llama 2 in its fine-tuned versions, right? So, and it's cool. But with GPT-4o, which is kind of one generation, even like gap. So basically we've trained 3.5 and this is 4.0. There was also 4 in between and stuff. Yeah, it is quite bad. So this is also like, to be honest, my talk should persuade you that there is so much stuff to do still in this disinformation resilience with AI. So I hope you'll see the point. And also we can see that Llama 3 and GPT-4o are actually like also quite far from all the data we had before. So that's also interesting. And like, with each new model coming, we have basically this new challenge. I'm actually almost coming to the end, so a bit of other slides, like of what's going on now, also what we are, like other stuff we are doing. So I said that we are doing this checkbot this for Faktan forum where you could participate, and it's cool. And basically the RAG is also one other thing which journalists accepted as a good idea and that they can use it and they are not afraid to use it. So what it does, maybe you all heard of RAG system, but I'll just explain again. We get user inputs, right? So for example, I don't know, some Klaus, we have a lot of Klaus in our community, can give us, so Klaus found some post on the internet and it's like, oh, I think it might be propaganda or it might be fake news and whatsoever. I want to check it with the community if the community wants to. And they propose it to us. And what we can show is, do we have fact checks already on a similar topic? So maybe we don't need to, Klaus, here it is. Or also what we can do is we can propose some learning material to, how to fact check. So for example, if Klaus is not sure how to check out if the video is generated, we can basically propose that. And the idea is obviously that we first pre-select candidates from our database of fact checks using a semantic search, and then we give it to LLM basically, like some. And what is also important here is to try to be flexible in the amount of candidates you propose. This is something we also found, because so the less you give, the best. So if you can limit basically somehow your candidate search, it's a good idea. Other thing we did is explainable model for deepfake detection. It's a bit unnerving, so I'll stop it. It's a really cool thing we haven't. So it was a bachelor thesis actually, a quite impressive one. And the idea of this bottleneck attribution is that we add some noise into the middle layers of our model, and with this noise we kind of then can, and we add this noise in different kind of places in a sense of the video or like of the frame, right? Because we anyway work on the frame. And by looking at how the performance of the model decreases, we can guess basically or say that this part of the frame was important. And then we get all the frames of the video together, and we can also check like what frames were more important. But the most important thing here is actually that we can say if the model says stupid thing. Because if, for example, like what is important for the model is like everything around the person, then, so I'll not go in much detail about it, but it's quite cool. Basically, it means that you shouldn't believe it, which is important actually for the journalists to be able to say if they have to believe it or not. And we also look at generated image attribution. We basically create spectral domain representations of the images, and then it's actually quite obvious to find like how to find them. These artifacts are very different between real models and real output or real image and not real one. What is interesting is that sometimes the difference between different fine-tuned versions of the same model and like basically the different models is even bigger than So you see, so it's actually also quite difficult field. Another thing one can do, and we did, is graph neural networks. So we basically took again German Telegram because nothing else is available, but it's obviously not very representative. So that's a short back of Telegram. And we, what is cool, we can not only use text then, but we can also use the forward information, likes, views, and we also connected each Telegram post we had that we could to a fact check from Corrective. So basically by similarity search again. And by this, we also were able to actually improve much more this kind of a disinformation cluster detection model. Also, by the end, I want to just show a bit of the industrial applications of this disinformation resilience with Mantis, where I work. Mantis is a Ukraine-born company, which is now working in US. We're registered in US, but we are like doing a lot of B2G, basically B2G contracts, for example, for the Defense Ministry of Great Britain or for Ukrainian Ministry of Defense. But we are trying to focus now more on the industry. And the idea, so one of the things we did is, for example, look at the election, not only US one, but like generally, you know, it's like super Valley year and stuff. So basically look at the narratives, which is like basically easily done with LLM. And then my work was also doing sentiment analysis, which is still so important for the industry and like so wanted, let's say. And the idea is that we are able to basically look at and compare the sentiment of the posts in American media on Harris as a candidate and on Trump. And what is even more interesting, we also are looking into Russian media and basically what they say about this and this way. So this is basically the project for the Ukrainian Ministry of Defense. And they are interested in like whom Russia is supporting really on like on which points they're like happy with which candidate. But the most kind of the cool thing now is event monitoring and verification. And this really becomes quite popular nowadays. I'm finishing. Yes. Basically, that I will just, that's the last slide, I think. So in the stakeholders, it's important to know that fact checkers and journalists as stakeholders are very skeptical and defensive because they are afraid that this kind of automation they'll take their job eventually. The industry is quick to implement, but they have no transparency. I don't believe they really think that they are implementing something very often. And then government is slow. And one of the things we learned is that actually like, many. So if in Germany it's like 4 departments interested in it, it's like 14. So that's one of the things. I think that's actually it. So one last thing I wanted to say is that both Mantis and one other startup I'm now currently starting to work in, which is called Omnicyto, which is a more of a bioinformatical startup, are interested in more like students, internships, and potential hiring. So in case of Omnicyto, we are very much looking into bioinformaticians. So if you're interested in either working in information, so like situation awareness or bioinformatics and stuff, you can write me. And generally, if you have any questions, write to this email. Yeah, that's it.
Importance work for society. I mean, in all these videos in text and in evaluation. If you have any question, please ask us. Raise your hand. We will have a microphone.
Can you pass it through?
Hi, Veronika. Thank you for the great presentation. I see you did a lot of work, lots of information as well. Great work. So I have multiple questions. I'll keep going until someone else has a hand raised, perhaps. Okay, so I'll club my questions into a theme, I suppose. So one is about the multiple languages thing. I think you mentioned multiple things, right? Like initially having a single model versus later having a split model in your flowchart, which you showed. Finally, what do you have? Do you have different tokenization for the different languages? Do you, again, eventually use separate models for these languages? Because we see that, for low resource versus high resource languages, the model performance is very different. Even the embedding are very different in performance, right? So eventually, what did you go with? And finally, what is the performance on different languages?
Mm-hmm. So basically, because it was a non-funded pet project, I stood on the I'm still on the point where I showed you, in a sense. So I hope that eventually now as a postdoc, I'll get like funding to actually continue this search. So for now, they basically have most of the languages in one model as a multimodal language. They actually still work fine. So I continue kind of doing some follow-up research and checking how it works. The worst, for some reason, not for some reason, works the Russian model because there was not so much actually neutral news, especially at that point, like in Russian, like basically dataset. And then it's a bit biased from the very beginning to predict most of the Russian text that more like propaganda. But basically then Italian model is separate and German model are separate. And they work quite nicely, actually. So except for this like user labeling, which showed that it was not perfect, when we come back now to the same sources, it still works pretty good. So I would say that on this point, I would still, at last evaluation, like German and Italian models were working around like 85-ish% in a year after training. And then the multimodal, obviously model depends on the language. With Russian, like very bad. With Ukrainian, quite all right, like 78%. With English, very bad, because we also didn't have much counter examples of propaganda in English. Now there's plenty, so this is one of the things one can do, and people already are doing. Yeah, and French also not so good as well.
Maybe I can talk to you because my thesis and master's was also around disinformation and the role of the translation, particularly. And my work, I also saw that the embeddings, the way you do this, there's big difference in languages, of course. Those and the embedding is important, plus features and stuff. So
Sure. Yeah, but with tokenization that you mentioned, it shouldn't be a problem because multimodal BERT model provides the tokenizer, which is multimodal, multi-language tokenizer. So this is not a big deal in this sense.
because they also have.
Yes. Sure.
Okay.
Hi, my name is Philip.
Hi, Philip.
I am German. I'm not that old, but I confirm I'm real. I have a question about this, what was it called? Propaganda classifier, let's call it. So I assume it's supervised machine learning. So what do you consider a ground truth for propaganda?
Yeah. So basically, as I said, for the later on when we had annotated but fact checkers, that was like just what they whitelisted and blacklisted as articles. So that's a bit clearer. With weak labels, as I said, we used like proxy kind of journalist investigations, which we looked at, which were confirming, for example, that some, especially in Russian case, it's a bit easier. So like the state sponsorship of some, for example, of some media. And then, for example, for Romanian, there is like a huge website like Rubrica.ro, which explains or like also puts, the bias of different media. For French, we actually also took like the Russian funded, basically Russia Today or something, but French version. So a bit like that. And in Ukrainian, there was a huge amount of investigations because it's obviously a big problem, like that some media in Ukraine are funded by Russian government. And then that's also quite a known information now. So a bit like that.
So it's just the funding, essentially.
Yeah, so basically our definition of propaganda was especially like the state funded. It's obviously simplistic in a sense that propaganda can be distributed by people who are not state funded, but just like just believe in it, or they think it's like, I don't know, like Elon Musk, they like posted and they're like disturbing or like interesting or stuff. But we're looking more at this definition.
Oh, one question about the detail. I mean, that's the foundation of your work. You determine the word by the type of it, the verb, a GLDV, something like that. Sorry, my English is not so good. But how could you get the score? It sounds like the embedding in transformer. So how could you get the score of each word? It is matter of yourself, or it is matter from another model? How could you get that?
Okay, let me try it. If I interpret correctly your question. So it was about explainability or about model performance?
What?
I didn't understand your question super well. I'm sorry.
That you determine different type about the word. You will say it's a verb. It's positive, it's negative, or something like that. Is it correct? And you will, I mean, it makes me feel like the embedding. It will give, make a list of them, and it will give a score of each type of it. How could you get the score?
Score of the words, right?
Yeah, score of the word in different type.
Okay, so all right. I think this in all of these different researches, we looked at different explainability models, right? So in the generated text detection, then Lime and gradients give their own scores. They are interpretable in their own like kind of the way. But we know that basically still if the score is big for basically either very big, so into the plus, or closer to 1 or closer to -1, then basically -1, it means that it's the negative class, +1 means that it's positive class. And we know that our negative classes, for example, human text and one is generated text. And then we can see, and we can also statistically basically kind of put some kind of threshold on what we define as like high and high score in a sense, right? So for example, if it's super close to one, but like there are many close to one, so then we differentiate a little bit what we took. But yeah, I don't know if that explains your bit. But you can also write me or like talk to me later. Because with microphone, I think it's a bit more difficult to understand.